Hello guys. We are going to go over our stoichiometry today. I understand it may be a little difficult for you guys to understand. Okay, I'm going to try to walk through this with you through this video, and we can meet whenever I return if you have any questions or need any extra help. But hopefully, since you guys have the basics of moles, this shouldn't be too difficult. Okay, so let's get into it. So it comes from the two Greek words stoichion, which means element, and metron, which means measure. It looks at different amounts of substances within a reaction. This could be substances before the reaction or substances after the reaction. Basically, it's just comparing the numerical relationship between reactants and products. The coefficients tell you a lot, okay? So these are going to be the important part. After you balance a chemical equation with the coefficients, you can then use those coefficients to tell you the number of moles of particles. So if we look here, it says we have 4Fe plus 3O2 makes 2Fe2O3. Okay? So the first question is, how many moles of iron do you have? In this case, we have 4 moles of iron. Okay, don't mind my sloppy handwriting. How many moles of oxygen do you have? Well, again, our coefficient is 3 for oxygen, so I have 3 moles of oxygen. And lastly, it says how many moles of Fe2O3 do you have? And in this case, we have 2, so our answer is 2. Okay, again, there's the answers for you. So, we must remember our law of conservation of mass, that mass is not created or destroyed, and mass of the reactants must be equal to mass of the products. So you have to find the mass of your element or compound. You can use the periodic table to help with this. And remember, you use subscripts to figure out the mass of the element or compound. Okay, so basically here we are just finding the mass of iron, the mass of oxygen, and adding them together. So our reactants total 319.4 grams. And on the other side, we are finding the molar mass of Fe2O3. And that comes out to be 319.4 grams. So again, the products are also equal to the reactants. And again, we already know how to do this. We're going to skip this practice since we do know how to do this, and I don't want you guys to be super bored with this video, so we can dive right into our new material. Mole ratios. Mole ratios are going to be our friend and our bridging gaps between equations. Okay, so it's a ratio between the number of moles of any two substances in a balanced chemical equation. Key word right here is balanced. All right, so if we take a look, we have 2Al plus 3Br2 yields 2AlBr3. All of these down here at the bottom, these 6 ratios, are the mole ratio possibilities that we could make. So let's find the mole ratios for the following. We have 4Al plus 3O2 makes 2Al2O3. So we could have 4Al for every 3 O2, 4Al for every 2 Al2O3. Also, since my handwriting sucks on this, I'm saving space by not writing the word mole. Okay, then we can have 3 O2 makes, or over 4Al, 3O2 over 2 Al2O3. And then we can have 2 Al2O3 over 4Al, and 2Al2O3 over 3O2. And those are our mole ratios for that particular balanced equation. So, using these, we can convert moles of one thing to moles of something else. Our question states, how many moles of hydrogen are produced when 0.04 moles of potassium are reacted? So I put my given out front. Okay, this is my given. So I have 0.04 moles of potassium. I use my mole ratio. For every 1 mole of hydrogen, I have 2 moles of potassium. So 1 mole of hydrogen for every 2 moles of potassium. And then I can cross out my units, multiply straight across. So we would multiply 4.04 times 1, then divide by 2, and then our answer is 0.02 mole of H2. Alright, let's do some practice. So how many moles of CO2 are produced when 15 moles of propane, which is C3H8, are burned? Okay, we already have our balanced equation on the screen. We put our given out front. Okay, this is our given. And we want to find moles of CO2. Okay? So if I have propane on top, I'm going to put moles of propane on bottom. So it's 1 mole of C3H8. And I'm finding CO2, so that's 3 moles of CO2. Okay? I can cross out my propane. When I multiply straight across, I do 15 times 3. My answer is 45 moles of CO2. Again, here's it a little cleaner since it's typed and not my sloppy handwriting. Okay, so let's take it a step further. We can go from mole of one element to mass of another element. Again, this is just building on things we already know. So what is the mass of sodium chloride produced when 3 moles of chlorine reacts with sodium? Okay, we have our balanced equation. We're going to go from moles of chlorine to moles of sodium chloride to mass of sodium chloride. Okay, so we start with our given, which is 3 moles of Cl2. We're going from moles of Cl2 to moles of chlorine. So here's our, or not chlorine, our moles of sodium chloride. Okay, then we have to go to moles or mass of sodium chloride. So we calculate the molar mass of sodium chloride, and then we can find the overall mass of sodium chloride that would be produced if I used 3 moles of chlorine. So let's go ahead and practice this. What is the mass of calcium chloride produced when 2.5 moles of hydrochloric acid is reacted in the following? So I'm going from moles of HCl to moles of CaCl2 to mass of CaCl2. Okay, so I put my given out front. I'm going from 2.5 moles of HCl to moles of CaCl2. So I need a molar ratio of HCl to CaCl2. I have 2 moles of HCl, so I put that on bottom. And then I have 1 mole of CaCl2. I put that on top. Then I have to go to mass of CaCl2. Okay, so I'm going to find the molar mass and plug it in here. I don't have a periodic table in front of me as I make this video, so I'm sure you'll see the answer on the next slide. And then we will put 1 mole on bottom. I can then cross out my units. I'm left with grams of CaCl2. Let's check out the answer. Okay, so the molar mass of CaCl2 was 110.98 grams. When I cross everything out, I multiply straight across. I do 2.5 divided by 2, press equals in my calculator, then multiply by 110.98. My answer then is 138.73 grams of CaCl2. Okay, let's take a moment to look at this review. It says balance the reactions, then write the mole to mole ratios for Fe2O3 plus C is FeCO2. Okay, so I have two O's on one side and 3 O's on the other. So most likely I'm going to have a common multiple of 6. So I'm going to put a 3 here and a 2 here. So now I have 6 oxygen on each side. My iron is going to be 4 on one side. I put 4 on the other. Now my carbon is 3 on one side. I put 3 on the other. So then I'm going to fill in my mole ratios. So I have 2 Fe2O3s for every 3 carbon. I have 3 carbon for every 4 Fe's. I have 3 CO2s for every 2 Fe2O3s. If I start with 3.4 moles of sodium hydroxide, how many moles of aluminum hydroxide are produced? Okay, you guys can practice these on your own and pause the video, and then we will move on. Okay, our final thing we are going over is mass to mass conversion. So we're going to go from mass of one thing to moles of that same thing to mass of something else to mass of that something else. Okay, this is all being put together now. So this says, what is the mass of H2O produced from the decomposition of 38 grams of ammonium nitrate? Okay, so we have our balanced equation. We're going from mass of ammonium nitrate to moles of ammonium nitrate to moles of H2O to mass of H2O. Here is what it looks like drawn out. We have 38 grams out front because that's our given. We have 1 mole of ammonium nitrate over our mass of ammonium nitrate. 2 moles of water to 1 mole of ammonium nitrate because that's our molar ratio. Then we find our mass of water, which is 18.02, and then we calculate by multiplying straight across. Cross out any cancellations of units, and we are left with grams of H2O. The answer is 17.11 grams of H2O. Alright, let's give this a try. So what is the mass of FeCl3 produced if 12 grams of Fe are reacted in the following equation? So we have our balanced equation. I have it set up. Mass of iron to moles of iron to moles of iron chloride to mass of iron chloride. My given is out front of 12 grams. Okay, I am going to fill in my grams of iron on bottom. Okay, again, I don't have my periodic table in front of me while I'm making this video, so you can find it on your own. Then I will put moles, 1 mole on top. I'm going to use my molar ratio of iron to iron chloride. So I have 2 moles of iron on bottom, and I have 2 iron chloride on top. Then I put my 1 mole on bottom for the iron chloride, and I'm going to have my mass of iron chloride on top. When I go to calculate, I'm going to cross out the units that cancel, and I'm going to calculate by multiplying straight across. So I do 12 divided by 55.85, press equals in my calculator, multiply by 2, press equals, divide by 2, press equals, multiply by 162.2, and press equals. Your final answer should be 34.85 grams of iron chloride. Okay, pause the video for a minute, take a moment to practice this on your own. You're going to find the mass of H2O produced if you had 24 grams of oxygen. Okay, I hope you solved that fairly easily. This will be our last slide. I can pull up our answer here. We have 24 grams out front. Our mass of oxygen is 32 grams. I have that one memorized. Then you put 1 mole on top. Our mole ratio of oxygen to O2, so we have 1 mole of H2O. We have 1 mole of O2, 2 moles of H2O. Oops, mole. 1 mole goes on bottom. Then we put our mass of H2O on top, which is, I believe, 18.02 or something like that. I'm just going to put 18, okay, grams of H2O. Now I'm going to multiply straight across. So I do 24 divided by 32, press equals, times 2, press equals, times 18, and I get about 27 grams of H2O. Okay, your number should be somewhere near there. I can cross out my cancellations. If that helps you out, I'm left with grams of H2O. Again, if you have any questions, please email me and make an appointment to come see me during ACT Lab. And we will get some more practice in the future. And next class, our quiz will be on, I believe, Thursday. Have a great rest of your day, guys.